So maybe I start like, if I would have known that the City University of Hong Kong is led by two professors originating from the States, maybe I wouldn't have chosen that time, because you know much more about gold rushes than a German guy like me. On the other hand, I really notice I'm somehow hit your heart with that. So maybe it's the right thing to do. So, dear Professor Ellis, dear Professor Rob, dear André Rogac, ladies and gentlemen, I thank you very much for inviting me to give this distinguished lectureship. I feel very honored, and I would like to explain you now why I call this talk the Nano Gold Rush. You could think about, since I'm from Munich, which lies in Europe, people think a lot about the euro at the moment, and people may flee into some other things like gold, but that's not really actually the reason. I'm not so much concerned about the euro. But since I'm currently doing my sabbatical in California, that may be part of the reason. When I'm there already since end of January, and as already noticed, the first gold rush was initiated in California, north of Sacramento, and a person called Captain Sutter, he actually came from Germany, from the southwest of Germany. There he was born. And he went to the States and bought some land, which he called New Helvetia, like New Switzerland, because he was living close to Switzerland. And he built a sawmill, and when the raceway of the sawmill was made, they immediately found some little gold pieces in the water. And that caused the gold rush. And there were lots of, as said, the gold rush was mainly the point that then lots of people came to California and trying to become rich very quickly. The sad point about all of this, most of the guys, including Captain Sutter, died in poverty afterwards, because at some point maybe people exaggerate and don't take it serious anymore. Okay, that may be part of the reason. On the other hand, what I find also very funny in this, that it says this newspaper here, on one hand, California now is rich in mineral wealth, great chances here for scientific capitalists, whatever that means. That's okay. So, but these gold nuggets for my talk are actually much too big and much too expensive. So I deal with something which is much, much smaller, namely, as you can see here, it has a diameter of about 50 nanometer, and those of you who don't know what nanometer is, this, the thickness of a hair is about 1,000 times bigger, and so we deal with very little things, and this is an electron microscope picture of such a gold nanoparticle, and you might envision that this must have been made by some experts like Professor André Rogac quite recently, but it was not. It was actually made more than 2,000 years ago by the Romans, because they already knew how to do that and made very nice cups out of these gold and silver nanoparticles. And one cup you can still see in London in the British Museum. And when you put some light bulb inside, the cup shows a red light. And if the light is coming from the side, then you can see here, you see some greenish light, some scattered light. So it has these two color effects like green and red, and the Romans liked it very much, and that's why they built it. And it's more than 2,000 years old, so as an optical device, it still works. And it shows that these kind of, if you make devices out of gold nanoparticles, they last. They are not bleaching like something organic materials, they really last. Good. So actually the recipe of doing that was kind of forgotten, probably due to the fact that the Roman Empire disappeared at some point. So another scientist, actually a physician called Cassius, he lived in the north of Germany, and he reinvented that recipe, and he called it the purple. It was called Purple of Cassius, and he called it ruby glass. And he made nice cups again, and also windows for cathedrals in Europe. They are full of gold, so it was reinvented. Nowadays it looks more not like art, but like chemistry, and people use aqueous solutions and produce these gold nanoparticles in these aqueous solutions. Okay, so we'd like to, so obviously these solutions don't really look like gold. I mean, gold looks like golden, and they look red and green, so what is that? For this, I don't want to go too deeply into physics or anything, but this, I think everybody learned in school. So what is gold is a metal, and what is unique for a metal is that all these metal atoms want to get rid of their electron. They would like to give it to the surrounding, and so if you put them together as a crystal, these electrons become free, and they kind of delocalize like a cloud in this metal crystal, and that leads to the fact that one has this negatively charged electron cloud, and that electron cloud can oscillate back and forth at any frequency on the background of these positively charged metal ions. And if now light comes, then this light, being a magnetic and an electric field, the electric field part, can start to let these electrons oscillate in front of the positively charged ions, and that works very efficiently, and that leads to the point that the light actually gets reflected from that gold surface, and that's why these gold particles, if you polish that, can be used very nicely as laser mirrors, for example. So why it's golden? It's golden from the reflection point of view. There's a reflectance plotted versus the color or the wavelengths of light. At longer wavelengths, the reflectance is very high. That's why gold is taken for mirrors in that wavelength. But at about 550 nanometer, the reflectance breaks down. So in the green and blue, these gold mirrors don't work anymore. And this is part of the reason that they don't look white like silver, but they look golden. Okay, now gold nanoparticles. For gold nanoparticles, the frequency of that oscillation of the electrons in front of these ions cannot be any frequency, but it's a frequency which is fixed, and it's called the nanoparticle frequency. So if light hits this gold nanoparticle, it cannot move around these electrons at any frequency, but just at this nanoparticle plasmon frequency. And this is very nicely seen in the scattering or absorption spectrum. So there's a huge resonance at about 2.2 electron volts, or in the green part of the spectrum. And this gives rise to this point that the green light coming from outside is scattered into the eye. So this is really making the game for gold nanoparticles, this huge resonance, and gives rise to what I said could be named the nano gold rush.